Hi, GM. I'm Samarth and today I'm going to be showing you how you can generate your first proof on Succinct Network. There is a slightly different gamified version of this made by Ivan and I'll link it down in the description so you can check it out. Before we begin, make sure you have Rust and Git installed on your machine, and to see if you have them, just open your terminal and run git --version and rust c --version. If you get an error, it means that you have to install them. Doing that is a pretty simple task. For installing Rust, you can just go to this URL rustlang.org/tools/install, and for installing Git, you can go to gitscm.com/downloads. If you have access to the testnet of Succinct and you've played games there, your balance will be showing up over here. This is the same number that will show up on this page, that is /explorer/account. However, you need to ensure that this address does not have any mainnet funds. So if the account you're using does have some mainnet funds, you can just create a new account in MetaMask or Ravi Wallet, whichever wallet provider you use, to get a new private key and thus a new address. This is not my mainnet account, this is a developer account, and I'll show you how I got credits over here. Let me switch back to my main account for a second, and yeah, this is my main account. So what I did was I went to delegations, add delegation, and added my dev account over here, which is this one. So let me switch back now, and yeah, I'll repeat because it is very important. Make sure that the account you're using for this tutorial does not have any mainnet funds. Now with that out of the way, let's get started. So we're going to be using a very simple addition program which adds two numbers and then gives us the sum, and then generate a proof of its execution on Succinct Network. I've created a GitHub repository for this tutorial, which is this one. All you have to do is copy this link, open your terminal and do git clone, then hit paste. Yeah, once that is done, I'll open my code editor over there, like so. cd succinct addition code.-r. Great, now this is the project that we're going to be working with. We'll be focusing on 4 main files and I'll briefly go over some other important ones. This is the .env.example file. We're going to copy this and paste it into a .env file, like so. Hit paste. These are variables that need to be accessible to our terminal. This value sp1 prover will remain the same for you. Network RPC URL will also remain the same for you, but this will be different. You have to copy your dev account's private key and paste it over here. Remember, it should not have any mainnet funds. So I'll just do that. Obviously, I won't show it to you. And yeah, that's done. Now let's check out program/src/main.rs. This contains our addition program. So as you can see, this reads two numbers over here. It adds them and gives us the computed sum. It also writes the output of the program to sp1. There are print statements to show you what is going on in the program. Now let's go to script/src/main.rs. Now this is what we'll be executing. So we're using the sp1 SDK over here and we're importing some components from it. We scroll down, it sets up a logger over here. It takes in variables from our .env file over here, and this part specifies default values. If you don't enter any numbers, it'll use these values and the sum will be 12. Let's go down further. It sets up a prover client using our env file. We specified in our env file that we want to use the network. So instead of generating proofs locally on our machine, we'll send these requests to the Succinct network. So if we mention that we want to execute it, it'll just execute the program and show us the output. However, if we mention that we want to prove it, it'll put in our program, a proving key, and our input values and give it to the Succinct network. Now let's check out build.rs. This is a very simple file which just builds our program with the arguments that we specified. If no arguments are specified, it'll use the values 5 and 7. Now let's check out lib/src/lib.rs. This file just contains a struct based on the structure of a program. So as you can see, A and B are our inputs and sum is our output. This will be used when you want to verify proofs on Ethereum. However, that is something we won't cover in this tutorial. Great. Now let's execute our program and generate a proof via Succinct Network. For just execution, the command you will have to run is this one. This is for logging to see what's going on in the background, and this is our main command. Now let's hit enter. This will take some time to build depending on your machine and your internet connection. You'll see a target directory over here as it builds. And yeah, now it will execute. Yeah, as you can see, we get the output with the logs. It reads A is equal to 5, B is equal to 7, and just sees if the values are correct. This is not generating a proof though. So now let's try generating a proof. The command you have to run is this one. Again, we set the logging level to info. The part before this double dash goes to cargo, and the part after this is used to specify that it is going to the program. And this will generate a proof on Succinct Network. Let's try it out. I'll run this command. It takes in the values, shows us the gas, and gives us more details. And yeah, we get a request ID and transaction ID. Our proof request gets assigned. And there we go. Successfully generated proof and successfully verified proof. Now we can see this proof request on the Succinct Explorer as well. Let's try it out. I'll copy this request ID from here. I'll go to the Explorer and I'll paste it. Let's go to this page. And yeah, as you can see, a proof was generated successfully. And this is the address I requested it from. So yeah, it's that simple to generate a proof on Succinct Network. If you have any doubts or run into any errors, you can either DM me or leave a comment down below. I'll make sure to respond to that. Thank you so much for watching. I hope you enjoyed and learned something new, and I'll see you in my next one. Thank you.